be shorter. So what I want to do is, in preparation for tomorrow's practicals where you are supposed to put your hand on a computer, kind of prepare from the ODV side of things. Before I go into the topics that we likely will cover tomorrow, I want to give a very brief overview of what to expect in the next release, which we are planning for this summer, basically. And we consider it a major new release, so we will terminate the ODV 4 series and move to ODV 5. Many things that have changed are not visible to you, but some will be. So the ones that, this battery is going. Do we have a better, I mean, it's almost invisible. Can you still see it? What is of concern to EMODnet and C Data Cloud is the importers that we will talk about and deal with. They have been completely rewritten. So for instance, the C DataNet importer will be about a factor of 10 faster, which some of you will appreciate. In terms of how it will be used, there will be no change. There will be change to the interface that I quickly will highlight. So the new application window of ODV will have an additional what I call view bar, which just like you are used from your browser, will have separate tabs, these things here, that contain separate views of your data file. So if you are new to ODV, maybe all this now sounds like garbage. Bear with me. It's just a very brief thing. Previously, you could only close a view and open another one. Here now, the ones that you have visited, they keep alive, and by just clicking on the tab, you can return to them. So very easily, you could have a full screen map sitting behind this tab and having a multi-window view like here, and on another one, you could have a section, but just clicking on the tab, you can move between them instantly. So that's more like browser-like experience. I should say you are still opening one data collection at a time, but you can have more than one view at those data. Okay, so now let's come to the topics that I think are relevant for C Data Cloud, EMODnet projects, the functionality that ODV is used for, and quickly go through them. The first one ODV gets involved is when a user or you have retrieved a lot of C DataNet ODV files and want to import them and work with them. So the first topic, import. I also would categorize this. This is the file aggregation. You have hundreds, thousands, or millions of files, individual files. You want to combine them all into one entity, which I call the ODV collection, which is a binary format. You basically don't need to know about it, but it's kind of combining the contents of all these hundreds, thousands of files into one package, basically, the collection. Sometimes we hear it's called the buffer, ODV binary sometimes. So that's created during that step. And the next release in summer will hopefully speed up that step, factor of 10, hopefully. The next thing, once you have this aggregated collection containing then everything that C DataNet has, is what we typically do, duplicates check. And that was an exercise we focused on, I think, 2 years ago. And that caused a massive cleaning up. My feeling so far is nowadays we don't have a massive duplicates problem, but still it was one of the important steps here. Third one, very important, you have heard that these hundreds of thousands of files contains a lot of parameters, and let's say for a given one like oxygen, it's typical that the files use 20, 25 of the BODC codes for oxygen, for instance, and you find them all. During this first step, they will all be treated as separate parameters. So easily, after this import, you have a collection and you have 20 oxygen parameters. Sometimes giving oxygen in different units also, because that mirrors what's inside the CDataNet files, and you have this variety. From a scientific or user standpoint, this is not acceptable. You want oxygen in a given unit. This step of what then is called parameter aggregation, so we unite a lot of these parameters, bring them into one common usable parameter, that's going under this P35 parameter aggregation term. In the way you invoke it in ODV is kind of the opposite of the import. You export the data again in a new ODV binary collection, but that now will contain the aggregated parameters, as you will see. So those are the typical steps that the regional leaders have been doing over the last 10 years or so, basically. Followed also by very intensive, labor-intensive data quality control step. And the capabilities and the techniques that ODV has for doing quality control and flagging those data points that you consider questionable or bad, that's what I would call number 4 in this pipeline of the workflow for CDataNet EMODnet project. And finally, for every change that anybody does to these data, changing values, it's possible. I'm not encouraging to change or to delete values. It's still possible. Or changing quality flags. Every such change that you do will be recorded in a history, what I call the history of the data, ODV data collection. The last step is how do I get out this whole record of changes that have been done mostly during the data QC. But also the history contains history information for every given station from which file was it imported, just to keep track on what was the data flow. And that's also important, the fact what has been done, but then also knowing which file the data values came from, and that's the objective of the project, if we want to feed back all these changes to the data centers where the data came from. Because otherwise, we would just do the changes in the binary ODV collection, and the data centers that hold the original data would not know about. And this is what we have to achieve, that this knowledge is fed back. So it's an essential step. How do I get out of ODV then the entire list of changes so that I can inform the data centers, please do the same changes in your original file. So in my vision, that's kind of the role of Ocean Data View within the CDataNet EMODnet project. And very briefly, I would walk you through these 5 steps, but avoiding details. But just seeing the difference of these import things. So in a CDataNet import, file import, that is triggered going to the main menu import, and among these many possible choices, choose SDN formats, CDataNet formats. Don't choose ODV spreadsheet. That was the topic we talked about before. These are different importers. They have a different understanding of what they are expecting. They both expect spreadsheet-like files, but they behave quite differently. So for us, within this project, it's really, this is the thing to use. Otherwise, you are not doing a proper import.
May I ask a question that is the format to expect that there is a zip file, or is there
I come to that. Okay. So when you do this, a file open dialog appears, and that allows you to choose files in different formats. So you can have zip files. Very often when people do a retrieval, or when Maris does a harvest, I'm getting zip files. And they typically contain 10,000 individual files, plus the CDI package in them. So you can, if you have received these zip files, just use them. Don't unpack them yourself. So the kind of files that are accepted are these zip files. If you have some individual ODV files, the TXT files, you can also choose TXT. The CSV is here because the CDI packages, they are .csv files. And also you can have netcdf files, the .nc files. And you can choose a mixture of everything depending on what you have. Typically, you have a number of zip files containing individual files. And you can choose one or all of them you have. If you have all your files, and let's assume it's many, in different directories, there's also a way of generating what we call a file list file that would cover an entire directory tree, and then during the import, during this step actually here, to present that list file that has all the paths of the files you want to be importing. And they can be spread out over your entire hard disk. So there are these possibilities. And once you started here, it's basically you go for coffee, if you have a lot of files. I should say there are a few dialogues, so maybe at the beginning you wait 5 minutes until you say yes and do some things. I think I've said all this. So I would move quickly to the next thing, duplicate checks. So after that step, and after you come back from coffee and eating lunch and so on, having it, and I should say for the entire CDataNet holding, it stays still, even with the 10 times speed up. So it's a massive thing. That creates the binary buffer, the ODV collection. And on that, you would do a duplicate check. And duplicate check in ODV, so you would have the collection open that has been created. Oh, I should say, during that import, there will be an analysis. Every individual file, after unpacking, will be looked at what is the primary variable Michel has talked about. And depending on what it finds there, for instance, a depth in the ocean or depth in the sediment or time, it will separate these data into separate collections. Because I mean, it's obvious, you don't mix a water column with sediment. They will end up in different collections. So depending on what you put in, you may end up with 3, 4, 5, maybe 10 separate collections, separated on the type of the data. And you have to work with all of these then. So if for a given one, like here in this case, you want to do the duplicate checks, you open that collection first. And then you go to Tools menu, and then there's this option, Find Duplicate Stations. When you choose it, a dialog comes up that lets you specify tolerances for the parameters that will be compared. And there are some defaults for longitude, latitude, and time. These are the parameters that are always compared. We are looking, are stations at the same location and time, date and time. But you can specify how tolerant you are. Normally, these are very tight limits, like a thousandth of a degree, which is like 100 meters, typically, and 1 hour. If ODV finds 2 stations in that collection that agree in position and time within these limits, they are considered duplicates, and they are added to a list of potential duplicates.
Does it take too long measurements?
No, but in addition to these mandatory, these are the parameters that are always considered in looking for duplicates. You can choose among the other metadata and add some other parameters that are also checked for matching. So automatically, by default, the cruise name is among them. So it's requiring that a duplicate is only a duplicate if the cruise name matches of the 2. But you can choose some others, like, for instance, the minimum and maximum depth of the sampling. If you want, sometimes you have duplicates, but they are not covering the same depth range. If you want to require that real duplicates, then you would specify. You would select them all. Here, you would select in the output that is written, which meta information do you want to have included? Do you want to have detailed knowledge of that station, or is it enough to have some basic? So you can adjust some of these things. And we could do duplicate checks tomorrow. So that's all I want to say with respect to duplicate checks here. The third thing then was, now we are having these collections with, let's say, 20 oxygen parameters in different units, and now we want to have a unified oxygen in a given unit. And that is done by this P35 parameter aggregation. And you should note, in ODV, you open the original collection that has these 20 oxygen, and then it's an export procedure. We keep that collection alive. It will not be changed, so you still have it for reference. If you later on you decide what you have done, since here is all garbage, you can go back to that. But it creates a new collection that now has these merging done, and also any unit conversion that is necessary to go from the original oxygen, let's say in milliliter per liter, has to go to micromole per something. All this is done automatically using a unit conversion database that right now we at RV maintain. And so when you start this export, as I have shown in the previous, once you have started this, what happens, ODV will go to the internet. If you are connected to the internet, it will get the latest P35 vocabulary from BODC, and it will go to our RV server to get the latest unit conversion database. If it's disconnected from the internet, it will just use the ones that were downloaded last time or that came when ODV was installed. When ODV is installed, I'm always packaging the latest that I have at that time. But easily, they get outdated. So for this step, it's good to have your machine on the internet, and it will get them. And so there will be 1-2 seconds of wait until these are grabbed from the internet, and then it will start doing the aggregation. And a typical output then is, when you look at the list of variables, these now look like the P35 variables. So for instance, we would have water body oxygen somewhere. Or here, water body phosphate, silicate, salinity, okay? So for every category, we just have one, and they contain all the data merged from the other parameters. So this step is really important. You may have parameters in your original file for which there is no P35 definition. They just keep untouched. They remain there untouched. And typically it's these ones. And the parameters are sorted. The nice ones, I would say, the P35 ones at the beginning, and then what could not be merged, because there's no P35 definition for them. So at that stage, I would say from the ODV perspective, we now have really aggregated things. We have pulled in these hundred thousands of files, and now we also have harmonized the parameters. And these get useful for users. Quality control. Within the projects, typically then the regional leaders get the data for their domain, like Mediterranean, Atlantic, and so on. And then they do quality control and pour them, because quality control is a really painful experience. It's also a very responsible task, because what you are changing here in the files, that get transmitted to the users or into Diva, into the product. So I think luckily we have dedicated people for all these domains that spent, I would say, significant time on them, and they do serious work. I only want to indicate the techniques in ODV that make this terrible task a little bit easier, I would guess. And the typical way when you want to quality control a set of data, and usually you have many more, like compared to this single section here, you would set up in ODV what is called scatter windows. Scatter windows, you can put anything on X and Y. Typically for ocean water column data, you put depth. You make profiles here. Scatter windows would show all the data points of all the stations here. So that typically gives you the best overview. And like here in this example, you see some immediate outliers. And if you just find these outliers, they have to be flagged so that all the users know we consider them bad data. Then you would click on it, and with 2 other mouse clicks that we can learn tomorrow, you would flag this data point. Here's another outlier. Here, this is a potential outlier, and so on. In addition to this purely visible, I mean, you look at it and immediately you say, oh my God. And then really clicking on those points and flagging them. In addition, there are what I call automatic range checks. So for every parameter, like for instance salinity here, you can say, please scan all the salinity values and everything outside an interval that you can specify. You can specify the valid smallest or largest value. Anything outside will be listed, and then you can do something with them, like flagging them bad. This approach, for some parameters, like here salinity, here we have an example where we have a large range of salinity. Why? Well, because some data go close to rivers. And that was actually my example I mentioned, I think, yesterday about It's dangerous to have a mean and a 3 sigma standard deviation criteria, because I would imagine some of these near zero values, they would be flagged out. And I'm kind of too cautious to let an automatic procedure kick data out. So here, if you look at the entire range, you can only specify quite broad ranges, and only these ones would be automatically flagged. But if you refine this a little bit by specifying depth ranges, like for instance, we are no longer interested in the surface one, so we are just looking at 500 and deeper. For these regions, oceanographers would be able to specify much tighter ranges. So that's what I'm encouraging, to have refinements to this automatic range checks, because now you can have much finer one. Some people would go further and make it much narrower, so that this one also would lie outside and they would be flagged automatically. So range checks can be refined, and they can make your life easier. And you don't have to click on these questionable points one by one, but just everything outside will be flagged as a candidate. There's a number of ways on how to assign these quality flag values. In the order of scope, they are listed like just for the current sample. So this is what you would use if you click on a point, you know that is bad. You would go here and just choose current sample, all the other ones untouched. But then you also could say, well, sometimes you know an entire station is bad. There's an option for this one. There is also, when this variable is in data windows, it's offering that all the samples in those windows can be flagged. So if before you have zoomed into those windows just to include the bad ones, then you would use this option here. And the other one, they are quite radical. I'm not... So the last one, for instance, wipe out all existing flags and set it to what you want. I'm not recommending that you use it. Okay. Well, and obvious, doing all this work has a benefit, because these flags can be used for filtering data. Like, for instance, for a given data window, we can now say we want to filter according to quality, and we tick the flags that we accept, and all the other ones we reject. So the typical set I find acceptable for CDataNet scheme is the first one, obviously, good value, probably good value. But probably bad value, you would not want to include bad value. I usually accept changed values, because when people have changed a value, that probably was for the better, hopefully. Value below detection, I definitely would accept, because otherwise you would throw away all the low-level values. Value in excess, I would keep interpolated value. Honestly, my judgment is these are not quality flags really, because they say something about some processing, and an interpolated value can be bad or good. Usually I include them. So this is my typical list of acceptable flags for CDataNet. When you do it, and you have done a good job in quality control, now you see a much cleaner thing. I mean, I think everybody agrees quality control is really necessary, because this is a typical case. And for tomorrow, I have a typical data set. And if you look at it first sight, you think, oh my God. If you invest time, and let's be honest, all this takes time, you have a clean data set. So it pays off. Okay, and finally, say something about this history and provenance. I mean, where do the data come from, tracking the data, which for every individual station, when you have it clicked, you can get the flags for that station by just putting the mouse over this element here. But at some point, you want to get all the history information out because you want to do something, like sorting them by EDMO code, and then sending the package to the different data centers. And this is done, well, that will be explained tomorrow. No, it's also an export, as you can imagine. So here I want to stop with this brief overview. ODV has a lot of other capabilities, but I think for the project, these are the ones. And the data center people who are using ODV for the processing of the data, and the regional experts for the projects we are in, they should know about these capabilities in depth. This list is much too many points to be dealt with in the maximum of 2 hours I think I have tomorrow. So now I would like to hear from you what of these points you definitely want to be covered tomorrow. Say again? Okay, I wanted to go on. I will hear this. I may not accept all the choices. Like if everybody would say quality control, I hate it, don't bother us, I would still do it. So quality control is booked. So what about, I mean, do we need to practice the import? So let's make democratic votes. Who wants to practice the import? Ah, very good. Number 1 is off. You want?
Yes, I would like to see how the file specify the location.
The file list generation. Okay. Yes, maybe that's enough for this, because it shows the flexibility on how you can choose your files. And that they can, I mean, if they are all in one single directory, it's simple with this dialog. You just say all, select all, and you have them. But if they are in separate directories, the file list is the only way to do it in one step. Okay, can somebody write this down for me so that I have a record? So otherwise, number 1, we keep still, right? So duplicate checks. Who wants to practice doing duplicate checks? Hey, what's going on? Who wants to do nothing? Okay, so duplicate check seems to be very disliked. P35 aggregation. Okay, we do it, that's the quickest because it's automatic, nothing to be done. But the idea is that everybody will do it in front of a computer, right? So you have a feeling of how fast it's going, what the result will look like, these kind of things, yes? Oh, you mean looking into files?
Not into files in unique converter, a file which is coming storing
Okay, so hopefully in the example files, there is a request for a unit conversion that is not covered.
Not necessarily it's not covered, but if they know.
Okay, yeah. Okay, so we spend some time on P35 and with a focus on unit conversion.
Yeah. Otherwise, again, we have a lot
Okay, I should say, in the end of P35, we have the unified parameters as they are described in the BODC vocab. So there's just one definition for oxygen. It's called water body oxygen or something. They also specify in what units that should be. And that will be the target unit. And the conversion, it depends on what was the original unit, but it all will go into this target. And if a certain conversion is not included in this list that I have briefly shown, you will get a dialog. For this P35, these data will not be used because ODV doesn't know how to convert them, but you will get a dialog which basically says, ask us at RV for that conversion. Usually, we ask back what formula. Because there are really exotic chemicals there, and we don't have any idea how that conversion should be done. So be prepared that we ask back to provide the formula. And then it will be added, once I put the updated unit conversion file on our website, we tell you, and then you can restart the P35 again, and it will work. And with some in this room, we have practiced, and it did work, right? Okay, so so we do some of this. Data QC. Are there special things that people would like to learn? I'm especially asking the regional experts whether you have some specific kind of test that you would like to do. Like, for instance, density inversions. That's a typical test. If that was your wish to see how could we do a density inversion test with ODV, then we put it up. So my question, is there a particular data quality procedure that we should practice?
If you want to show this, that's a conversion that consists of making another kind of element.
So density inversion, is that something? Well, we will need to do some derived variables in between. So density inversion. Michel, do you have it? I think this I just have to do so that you know how to get the list of all the changes out, and that you see where's the ETMO code, where's this, how to sort it with respect to ETMO codes, and then send this part to data center X, this part to data center Y. Okay? So I think we have a plan, and let's see whether 2 hours are enough to do it.